All right, good morning, folks. Wanted to wrap up a couple notes from third hour today. For those of you that are gone or missed class, you can take a look at this or come back to it for help as needed. So I'm going to go back through today's lecture and, like I said, include a part I didn't quite get to third hour, but we are focusing on dilution today. All right. And what we said is, lab reagents, they're often purchased as concentrated solutions, and it's for reasons of safety or being economical, space limitations, easy to transport. And often we must dilute a solution to a larger volume to make a less concentrated version for what we're working with. And this will certainly be the case after spring break when we prep our own solutions for a lab. To consider what dilution means, we're going to define some variables. We're going to define M1. This is the molarity of a solution before we dilute it. And V1 is the volume before we dilute. Okay. These two comprise what we call the stock solution. So it's what we start with before we do any dilutions for the experiment at hand. Then we have M2, which is the molarity after dilution. And V2 is the volume after dilution. So with dilution, we are making a less concentrated solution. So we're going to take some amount here and we're going to increase the volume from before to after, but as a result, it becomes less concentrated. Also remember from earlier this week with molarity, we defined molarity as the moles of solute divided by the liters of solution. And if we rewrite this, we can say that the molarity times the volume is equal to the moles of solute. Now, a point that we made in class at this point is that when we go to dilute from one volume to a larger volume, the number of particles represented by moles of solute does not change, which means that the moles before equals the moles after. Okay, so the moles do not change before or after the process. If that's the case and these are equal, well, we can take what we did here and substitute down here to say that the molarity before dilution, which was M1, times the volume before dilution, or the liters, is equal to the molarity after dilution times the volume after dilution. And this is the equation that we'll use for dilution. Okay, we will always be given 3 out of the 4 variables and solve for what's missing. So we can do that relatively straightforward. Here's a problem for us to take a look at and practice this. Calculate the molarity of a solution made by diluting 0.050 liters of a 0.10 molar HCl solution to a volume of 1 liter. Okay, so calculate the molarity of a solution made by diluting this volume of this concentration to a bigger volume. Now, what I didn't say before as we look at this equation here is M1 is always going to be our big concentration, and M2 is going to be the small concentration. Think about it. We have something with a large concentration, and we add water and we dilute it so it's weaker, so a smaller concentration. Consequently, we take a small quantity of our initial stock solution, we add water, and the volume increases. So V2 should be the bigger value. Okay. Remember back in English class learning about prepositions, right? They talked about or gave us an idea about relationship. So for example, 0.05 liters of 0.1 molar HCl solution, it tells us that this volume belongs to this concentration. There's relationship there. 0.05 liters of 0.10 molar. They go together. And we're going to dilute it to a volume of 1 liter. So I know that these two go together. I know that there's this volume and then there's a molarity we're solving for. But what variable is what? Well, if I look at the two volumes, this is the small volume, this is the big volume. So must mean that this is V1 and this is V2. And if this volume is related or belongs to this concentration, then that concentration has to be M1. Okay? That means that we're going to solve for M2 here. So we'll set up our equation. M1 V1 equals M2 V2. We have 0.10 molar times 0.050 liters equals M2 times 1.0 liters. Okay, we are solving for M2, so divide both sides by 1 liter. Our liters cancel, giving us molar, which is what we want. And when we do the math and calculate, M2 comes out to 0.005 molar, and that's of that HCl solution. Okay, so that is the result that we get, and it should make sense. We are taking this volume of a 0.1 molar solution, we're adding water significantly, up to 1 liter, which means we should have a smaller concentration, and that concentration is indeed smaller than our M1, so that works for us. Okay, let's go on and take a look at another sample problem. Okay, this example says the following. Calculate the volume in liters of water that must be added to dilute 20 milliliters of 12 molar HCl to 0.100 molar HCl. All right, so this one's a little different. They want to know the volume in liters of water. So what it tells us is we're taking 20 milliliters of 12 molar, and we are diluting it to 0.1 molar, which means that even though the volume, or I'm sorry, the molarity goes down, the volume should go up. So in order to find our volume of water, we are taking the initial volume of our 12 molar sorry, we're doing our let me rephrase that. Our final volume is our initial volume plus the volume of water. Okay, so we're taking initial volume, the 20 milliliters, we're adding a certain amount of water to get to this new volume that's much bigger. Okay, well, in order to find the water, we can rearrange it to say V2 minus V1. Okay, that still doesn't help us because, or not yet at least, we know V1, we don't know V2, and that's what we have to solve for. Back in our problem, 20 milliliters of 12 molar solution. Okay, they go together, and we're diluting it to 0.1 molar. Since we're diluting it to the smaller concentration, that means that's V1, and this is M1, and then this is M2. So our equation, M1 V1 equals M2 V2. Plug in what we know. 12 molar times the volume. Now, real quick, they want us to find this volume in liters. It might be helpful to do it now. So this volume here should be 0.02 liters. And we'll plug that in here, 0.0200 liters is equal to M2, which is 0.100 molar, times V2. That's our final volume. And when we solve for V2, so divide both sides here by 0.1, all right, the molar cancel, we're left with liters. V2 is equal to 2.4 liters. That's the solution. All right, that's our V2, and we know our V1, so we can come back to this and say, well, hey, the volume of water that we have to add is equal to 2.4 liters minus 0.02 liters, which comes out to 2.38 liters of water. So to answer our question, calculate the volume of water that must be added. Hey, we're going to take 20 milliliters of this 12 molar solution. We're going to add 2.38 liters of water, and that's going to dilute it to 2.4 liters of a 0.100 molar solution. Okay. Some folks might wonder, like, can I keep my volume in liters or milliliters? Do what the problem's asking you. If it just says to find, molarity, and you're given milliliters for both V1 and V2, don't worry about changing it to liters because the units will cancel. All right, not something to worry about there. All right, that's it for this tutorial. Good luck.